In today's lesson, we are going to be looking at the perimeter and area of composite shapes. So in our first example, we want to calculate the perimeter and area of this composite figure. So what we have here is what is called a composite figure. And by looking at it, hopefully you recognize that this isn't one of our normal shapes, right? It's not a square, it's not a rectangle, it's not a circle, it's not a triangle or a trapezoid or a parallelogram. It's not a shape that we have a specific formula for. And composite shapes or composite figures are made up of those basic shapes that we do have our formulas for. So when we're trying to find the perimeter and area, we might have to break up our shape or our composite shape into those basic shapes that we do know and that we do have formulas for. Now, right now, when we're trying to find perimeter, we don't really have to do anything in terms of breaking it up because I have enough information in my diagram here to help me figure out what the other sides are. Right? Looking at the sides, we can see that there are these little markings on each side. Right? And what this is doing is this is telling me that there are other sides in this figure that have the same measurement. So for example, we'll color code it. So these little three lines here are similar to here and here. So what that does is that tells me that this side is 12 centimeters and this side has a length of 12 centimeters. These little markings of 2 tell me that all of those sides or those lengths are 4 centimeters. And then the last one, so a mark of 1, tells me that these two sides are 2 centimeters. Now that's enough information because the perimeter is the distance around this object. So I want to calculate or basically add up all of these side lengths around my figure to find the perimeter. So in this case, P is going to equal, and a helpful thing is to just pick one side. So I'm going to pick and start with 12. And then what we're going to do is we're just going to go clockwise around our figure. So 12 plus 2 plus 4 plus 12 plus 4 plus 12 plus 4 plus 2. So I'm just doing that just because with a figure, depending on how many sides it has, there could be a possible scenario where maybe you just forget, or maybe you don't count a side, or you forget a side, or you miss a side. So it might be a little bit helpful if you pick a side to start with and then just work your way around clockwise. Again, whatever strategy is helpful for you. Maybe you go through and you cross off each side as you add it up, or you put a little mark above or at each side when you add it up, or when you add it. Whatever works for you. So I'm going to go add up all those values, and I'm going to get 52 centimeters. So therefore, the perimeter is 52 centimeters. No unit or no extra units or no extra signs on the units when we're dealing with perimeter. But that's the perimeter of this composite shape. Now for the area is going to be a little bit different, right? Because the area is everything inside this figure. And for area, we do have specific sides, right? So what we need to do is we need to break this shape up into those basic shapes that we know. And there's different ways you could do it. There's more complex ways, right, depending on how we want to break this up. We could break it up into, say, let me do a different color. We could break it up, say, into 2 little rectangles and 1 long rectangle. We could split it up this way into 2 rectangles, right? There might be other ways, but those are probably the 2 ways that might first come to mind. Now again, whichever way you choose to do is fine. It might be a little bit more work. So I would say, let's just go through and we'll split it up this way. Just make it 2 rectangles. It'll be less work. There's only 2 calculations we kind of have to do separately, and then we're going to add it up. So I'm going to label the long skinny rectangle A1 for area 1 and A2 for the other one. And what we're going to do is we're going to find the area of each figure because those are basic shapes. I know the area of a rectangle, we've looked at it before, is length times width. And in that case, I can also do the area of the second shape, which is a rectangle of length times width as well. And because I know those formulas, I have a formula sheet that has them, right? I can find the area of those two shapes. So for the first one, it is 12 times 2, or 24 centimeters squared. The second one is going to be, we've already mentioned in our last example, this side is 4 and this side is 12. So 4 times 12 centimeters, or more units right now, 4 times 12 equals 48 centimeters squared. So now that I have the area of each figure, or each basic shape of this composite figure, to find the total area, I'm just going to do area 1 plus area 2. I'm going to add those two together. So 24 plus 48 equals 72 centimeters squared. So therefore, the area is 72 centimeters squared. So just adding those two areas up. And that's really all we have to do when we're dealing with composite shapes, is just understand, can I break it down into the basic shapes that I know, right? That I have formulas for. Because once I can do that, I just have to determine make sure I have the right side lengths, and then I can just plug it into my formula, add them up, and I have the area. Let's look at another example. So here we're going to look at a more complex shape. It's still a composite figure, right? Because we can see that it's made up of a bunch of different figures. We can see a rectangle, we can see triangles, we can see a semicircle, right? So there's a little bit of work that we need to do here. I need to find the perimeter and the area, but right now we're going to focus on the perimeter. So I have some measurements. I see 3 centimeters, I see 3 centimeters over here, right? Because of those two that little line. I know that these two sides are going to be the same. I can tell that then the middle has to be 10 centimeters just based off the diagram. I can see a rectangle. Right? I want to find the perimeter. And we want to make sure that when we're looking at these figures, when we see these dotted lines, right, or maybe it's not a dotted line, but if it doesn't mention anything about, say, like a scenario where maybe it's fencing, right, where this is fencing in the middle here, assume perimeter just means the distance around the object. So that's going to mean like all this area. So that, or not area, but that length, that entire length, that is what we need to add up. Right? We're not worried about anything on the inside. Those dotted lines are just there to help us figure out what the shapes are, right? So it gives us a little bit better idea and helps us come up with some of the measurements that we're going to need to help us find the missing sides. Now, there are a couple sides we're missing. We're missing this length here, but based off of what I can see, it's going to be the exact same length. And I am also missing this length here. So let's label some of these sides. I'm going to call this C, and you can probably guess why I'm going to call those two sides C. Right, they are the same, so I'm going to label them both C. And then we can pick another letter to label this side. Right, this distance, this semicircle. Let's call it F, or we'll call it D. It just comes after C. Doesn't really matter what you label it. I'm just doing it for sake of, so when we do the calculations, we know what we're referring to. Right? So C represents these two diagonals of a triangle, and D represents the rounded edge, this semicircle. Now looking at this triangle, hopefully we recognize that it is a right angle triangle. We see the right angle symbol down here. And then we learned in our previous lesson how to find a missing side if we have two other sides of our right angle triangle. And we do have two sides. We know that one is 4 and one is 3. So if I look, I should be able to use my sum of squares or my Pythagorean theorem. Same theorem, just two different names, means the same thing. Using the measurements that I have. 4, 3, and C for my hypotenuse. So that's why I labeled it C. I can take those values, plug it in. So 4 squared plus 3 squared equals C squared. C squared equals 16 plus 9. C squared equals 25. And then we want to square root that. So C equals the square root of 25, which is 5. So that tells us now that these measurements are 5. I'll put a C there just so if you're looking back or just looking at the final note, you know what we're referring to. So those two lengths are 5. Now for D is going to be a little bit different. Right? D is a semicircle, or the edge of a semicircle. Right? We do have a formula for the circumference or the perimeter of a full circle. Right? So we think of a full circle, that circumference, or we'll say D, is equal to, we'll call it perimeter, or we'll do capital C for circumference. So pi times diameter, right? Or 2 pi r. We're using pi times diameter because we have the diameter of our circle, right? The diameter is this distance across, right? From one edge of my circle to the other, right through the center. So I have the diameter, so I'm using the pi times diameter formula. But because it's a semicircle, I don't want a full circle. I want half a circle. So I need to take that pi times diameter and divide it by 2. So that capital C for circumference, we're going to replace that with D for the side that we labeled. Actually, let's label it E after D. We don't want to get it confused with diameter. So E is going to equal pi times diameter divided by 2, or pi times 10 divided by 2. When I go through and calculate that, remember, you could use the pi button or 3.14. You should get 15.7 centimeters for E, or this curved edge of our circle, or semicircle. So now I have all my sides. I can go through for perimeter and add them all up. Right, again, pick a side that you're going to start on. Let's say we're going to start on over here and just work your ways clockwise. So we're going to say 5 plus 15.7 plus 5 plus 3 plus 10 plus 3. I made it back to where I started. So P equals 41.7 centimeters. Therefore, the perimeter is 41.7 centimeters. So again, I had to do a little bit of work to find some of the missing side lengths, but if we had to do that, it's either going to be a calculation using Pythagorean theorem or sum of squares, or using our circumference formula for a circle, or it's going to be some sort of common sense or general reasoning based off of the other sides that we have. So maybe we're adding or subtracting 2 lengths to make up an overall length, something like that. So if we're missing a side and we need it, we should have the tools to be able to solve for it. Right? You might have to do some calculations, but it should be solvable or something that we can find. Now for area, we can hopefully see the different shapes because it's already kind of broken up like that. Right? The dotted lines help visualize that. But if they weren't there, you would have to draw those in so you get a better idea of what are the basic shapes we're dealing with. And looking at this figure, we can see that there are at least 3 different types of shapes. We can see the 2 triangles, and they are going to be the same. So I'm going to call it A1 for both of them. We have a semicircle, or half a circle. I'm going to call that A2. And then we have our rectangle, A3. So I'm going to find the area of each of those figures and then add them up. right? So A1, my triangle, right? Base times height divided by 2. If you don't remember that formula, it comes right from the formula sheet. So base times height, 4 times 3 divided by 2. I get 12 divided by 2, or 6 centimeters squared. For my semicircle, for area 2, area 2, the formula for a circle is pi r squared. However, because it's a semicircle, I need to divide by 2. So pi r squared divided by 2, pi times 5 squared divided by 2. Remember to follow BEDMAS, so we have to do our exponents first. Pi times 25, or 5 times 5, divided by 2. And we get 39.3 centimeters squared. And then lastly, for our rectangle, area 3, easy one, length times width, 10 times 4, at 40 centimeters squared. Once I have all of those, now I can go through and just add up my different areas. So the area total, let's use a different color, use purple. So area total is going to equal 2 times the area 1, because I have 2 of those triangles, plus area 2 plus area 3. So 2 times 6 plus 39.3 plus 40. We add all of that up and we get 91.3 centimeters squared. So that is our total area of this composite figure. So therefore, the area is 91.3 centimeters squared. So again, nothing new in terms of formulas, right? We should have seen those formulas before. We have the formula sheets that will be able to give us those formulas so we don't have to memorize them. But the idea is that we have to break up our composite figures into those basic shapes to then help us, or which will then allow us to calculate the area of those basic shapes. And then we're going to just add them up to get our total area. Now, keep in mind, a composite shape could be where we subtract some figures as well. So what I mean by that is maybe we have a rectangle and we take a triangle out of it, right? So we have a rectangle minus a triangle. So in some cases, maybe we might have to subtract an area from another rather than add areas up, right? Just something to keep in mind depending on what composite figure we get, but it might not necessarily always be adding.